All right. Thanks everyone for joining our third installment of our online Q&A series presented by the RMIT Mechanical and Automotive Engineering Association. This week, we have three of our own RMIT academics from the School of Engineering. We have Professor Kate Fox, Professor Kiao Inthavong, apologies, and Professor Abhijit Date. Today, they'll be talking to you about research at RMIT, the opportunities that are on offer, and what career paths can you achieve from conducting research or postgraduate research. We'll begin this session by going through a number of presentations, and then we'll finish the session hopefully before 7 p.m. With some questions from the audience, which will be asked through the chat. So any of you guys can go first. I don't mind, but take it away. Good luck.
All right, maybe I'll go first because I'll give you a sort of how to do a PhD here, and that might sort of start the conversation a little bit. All right, can you all see my slides? Yep, cool. All right, so my name is Kate, and I'm the Associate Dean here who looks after the high degrees by research. So my background is engineering. I'm a biomedical engineer by trade. But when I joined RMIT, I actually joined the mechanical engineering department, because what you'll see when we sort of talk about PhDs is that it doesn't really matter what your background is. You sort of follow the projects that interest you the most. So at RMIT, we have a really large cohort of PhD students, and we like to think of ourselves as, above world average, and particularly around mechanical engineering and manufacturing. We rank really highly amongst all the other international universities. So it's a pretty cool place to do a PhD if you're thinking about a high degree by research. When I say that, it doesn't have to be a PhD. It can also be a master's or any other research degree along the way. If you're sort of thinking about it, we do have student reps who are already HDR students. And I put their names up on the screen here. I'd be happy to pull you aside and have a chat if you want to sort of see what it's like from a student perspective. And then every discipline, your discipline mechanical has Peter Dabnitsky as the HDR manager within your school. Any of those three people are great people to tap on the shoulder and sort of ask questions. I guess for you guys, the reasons why you might want to do a PhD here is every student is given, I guess, a little bit of money to be able to support themselves in their candidature. What we prefer you to do is to be able to come on a scholarship. And for you guys, the end of year round usually opens around October. And the scholarships you apply for, whether you're domestic or international, is you're looking at about $31,000 a year, I guess, scholarship money, but also you get a fee scholarship. So it covers all the fees of the program. So it won't cost you anything if you're able to apply for a scholarship and get it granted. So they open in October. It's a little bit earlier if you're an international student. There's an EOI process which sort of precedes all of this, and then a little bit later for the domestic candidates. But it's sort of, semester 2, keep your eye out on the RMIT websites, because academic staff will sort of tap you on the shoulder, go speak to them about the projects they might have up to offer. What we do here at RMIT is also a little bit different, where, as I said, they'll give you $3,700 across your PhD to be able to travel, which is a little difficult at the moment, but theoretically travel. But the other cool thing we do is we give you some money in your pocket if you're able to publish manuscripts in high impact journals. When you do a PhD here, it's not just about the research. We also try to give you the skills outside of, one-on-one research around a bit of media training, a bit of commercialization, and all these soft skills that will make you a bit more employable at the end. Really, what we're trying to do here at RMIT if you choose to go down this path, is provide I guess a higher level of graduate who can go into industry and can go into the jobs that you're looking at now, but at a level a little bit higher, with all the soft skills, but also a very high technical background. So you can come in and you can be a manager, you can be really useful to the organization, not just because you're really good at making a little widget, but because you're a great communicator, you're great at tech transfer and all that sort of stuff. So we try to make sort of well-rounded PhD students at the end. I guess when I finished my undergrad, I had every intention of never doing a PhD, like ever. And I was going to go off, I was going to join defence. So my capstone project was in designing an antenna that could control electronic warfare in those sort of applications. And I was all good, I was about to go join DSTG, but then the war in Iraq broke out, so you can figure how old I am now, and they rerouted all of the graduate funding. So it may be quite similar to what you guys are facing right now, where all the graduate programs are getting a little bit tighter, and the money just isn't there that was 24 months ago. So I ended up doing a PhD through a industry partner, and I thought, oh, this is going to be sweet. They're going to give me all this money. It's all tax-free. And I turn up on day one, 3 years later, I'll be a Dr. Kate, and then I'll go on for the rest of my life. But when you do a PhD, I guess you need to understand that there's a lot of complications, because you go in with really great expectations that you know the solution to your problems. But the thing about a PhD is that if there was a solution, it wouldn't be a PhD project. So reality of a PhD is very much you have a project that you're expected to complete across a 3-year period, but you'll find a whole heap of more questions every time you try to solve one question. So it's a bit of a journey of highs and lows. So if you are thinking about this pathway, prepare yourself that it is hard, it is study, it is a complicated degree, and quite deliberately so, but you'll come out the other end of it really well skilled and really well prepared for whatever comes next. We try to have a nice sort of social environment around our PhD students. At the moment, we're looking at probably 600 in our school across the 7 disciplines. So not just mechanical, the whole way across to electrical and civil and environmental. But we try to get them all together the best we can to try and create networks, which is really important if you are from interstate or overseas, where you don't have the immediate networks already here. So we try to run lots of events for you. I guess my research area is I work in implant technology. What I do, and quite often I'll take on mechanical engineering graduates, and I do that deliberately because I don't need a biomedical engineer. I already have me. I'm looking for people who have a whole heap of skill sets outside of biomedical engineering. So additive manufactured design, prototyping, design for manufacture, all these things that my group doesn't already have. So it's really important to note that just because you've got a mechanical engineering degree, it doesn't mean that you can only apply for mechanical engineering projects. All right, have a look. Engineering's got a project list that gets updated every 2 or 3 months. You can see the whole list of every academic staff member within the School of Engineering and all the PhD projects and master's projects that they have on offer. So I put the link up there. You can type in anyone's name, any area, keywords, all that sort of stuff, and you can really see a whole list of projects that might appeal to you. If you type in me, you see mine's all about implant technology, but you type in Kiao, and I'm sure he's probably got a slide that has something similar. But you'll see that even though I sit in the School of Biomedical Engineering, my projects apply to mechanical graduates, materials graduates, mechatronics, you name it. So don't narrow yourself down to just the projects of the supervisors that have taught you throughout your undergrad. Look throughout the school and you'll probably find some really interesting things that will appeal to you. So I've tried to go through that really quickly because I know you're about to have 2 more speeches after mine. But feel free to send me an email about any problems you might have, any considerations. My job is to look after PhD and HGR students, so I'm always happy to have a chat about whether it is the pathway for you. All right, I'll hand over to Kiao. He's next on my boxes. Thank you.
You gotta unmute yourself, Kiao.
Okay. Sorry about that. So for my presentation, I thought I'd give a background of my academic career and how I ended up at RMIT. Whoops, I think we need to go to presentation first. So I finished my PhD in 2009, and I thought I'd give you the dates so that you can kind of see where the pathway led me into academia at RMIT. So although Kate said 3 years to finish your PhD, I took a little bit longer. So I took about just under 4 years, so 3.5 years there. Surprisingly, my bachelor's was in heat exchangers in mechanical engineering, but when I did my PhD, it was in spray atomization. So here's an image of what we were doing, and that led to nasal drug delivery. And so you may have seen the image behind my back. And I'll get onto that later on and explain the significance of it in today's environment. Okay, so after you do your PhD, you go out, and if you want to stay in academia, then typically you do more research as a research fellow. And while you're doing that research fellow position, then when there's a position that comes up as a full-time academic, then you can take that opportunity. So my path was that I finished my PhD, did a postdoc, and then jumped into RMIT as a lecturer. Okay, so what do I do as a daily routine? Well, in terms of my job and the roles I undertake, so teaching duties is probably about 20% or 30%. We also have administrative duties. So this is ensuring students have the best experience, the management of our programs to ensure our programs are of the highest quality, that because we do get our degrees all accredited, and also engaging with the discipline. So what things can we do within mechanical and auto to ensure that everything that we do is at the top of its game? So, that comes down to even the lab equipment that we have, the software is the latest software that industry is using. We also try to engage with our industry partners, because the relationships with the industry partners is extremely important for all of our work. This is where a lot of our projects come from, and also funding for research. There's also a lot of time spent in disseminating our outcomes. So when we do the research, we get some awesome results, and from that we really need to know how to get that out there to the public domain. So that's in journal publications, conferences, conference paper publications, magazines, industry magazines, and we do a lot of grant funding applications. So if you've got a great idea and you want to work on it, then it's ideal that you can get some money to support that research. And so we spend a lot of time asking government to have some money that we can spend, and that money we spend on student scholarships, equipment that we need, and postdocs that we can hire to help us with the research to get our idea out there. International collaborations is also important, but I think this part of my role is probably the most enjoyable, because getting to work with people from Europe, America, it's great because you get a chance to see what they're doing. You get opportunities to go visit those universities. You spend time at their campuses. So last year I was out at Duke University visiting American college life, and it's completely different to here. And then other times you might go, I went to Japan to visit another collaborator. So that's probably a really, I think, yeah, a really enjoyable part of being an academic is the international collaborations that we have. Now, conference attendances. So I think this, I could say, for most academics is a highlight because we get to see our peers share their work, and we also get to share our work, and it's a great opportunity to just, you know, let our hair down a bit and talk with like-minded people in our field. And, you know, it also gets us to see what everyone's doing, and then we may get some new ideas for advancing the current work that we do. So, you know, out of all this, you may think, oh, you know, why would you want to do postgraduate study? Well, I think the thing that you can get out of it is this completely different way of thinking, and you really will get challenged about how you're learning and what you're learning. Okay, so I thought I'd just talk about some of the projects that I do at RMIT. So I split it up into two. The first part here is multi-phase flow. So this is to do with fluid particle dynamics and computer modeling, and essentially seeing things that we can't normally see with our eyes. So we need to use computer models and also special lasers that help us pick up very small micron particles and microscopic scale levels to see those particles moving in the air. And the application that is the inhalation project. And so here we're looking at fundamentals of fluid particles or aerosols in the air and how it's delivered into the nasal cavity. So this animation here is the nasal cavity and these droplets that are being sprayed into the nasal cavity is a form of drug. So we're trying to target certain regions of the nasal cavity to deliver drugs. And I did mention that the image background behind me. Well, this is a person sneezing from the nose, and we've had I've had a few ENT specialists come and approach me to see, you know, to discuss, is sneezing really that dangerous, and what is the distance where we need to be to ensure that we're safe when we're doing surgery. So when you start doing your own research, you kind of get into the field that you like, and then you can really have impact on society. So the current work we're doing is to investigate this safe distance for surgeons when they're operating and doing endoscopic visualization of the nose. Okay, so just as a summary, I'll go really quick here. This is a summary, one-page summary of the work that I'm currently undertaking. I'll just reiterate what Kate said. You know, I started off as a mechanical engineer. I did heat transfer and air conditioning systems, but I ended up looking at nasal sprays and drug delivery. And I've learned a whole load of medical terms and biomedical knowledge. So whatever, you know, despite learning mechanical, I think the skills that you learn in undergraduate is translated into this more advanced mode of learning. So it's more about being able to apply your learning skills into a topic that you really enjoy. Might just go through these quick. So these are just so you know, these are different types of visualizations, really looking at the microscopic level. So these are drug particles that are moving out of this nebulizer that you saw. And then so we combine macroscopic visualization, microscopic visualization, computer modeling to characterize the spray. So a lot of it is, you know, really intensive computer modeling. And we're trying to help these ENT surgeons. And this company here is redesigning this bottle that we've been working on for them. And so, you know, we try to have impact with our research as well. Okay, so how to get into the research? Well, I think Kate's already talked about this, and that's, RMIT offers these awesome scholarships, and I think right now there's huge opportunities for domestic students. The reason being is that each year when students apply, the number of domestic students applying is much, much less than the number of international students applying. And so when you're applying, you've gone in, your application goes into a pool, and then you're applying against those domestic students. And so, if the numbers are small, then of course you have a better chance statistically. So by that, yeah, I have to say that there is a really good opportunity, and the scholarship is a tax-free scholarship, so it doesn't count towards your taxable income. Um, so I think that's a great thing, and I know that a lot of my friends, when we finished, a lot of my friends went straight out and worked in industry because they didn't want to do any more studies, and I ended up just, yeah, doing my PhD. So that's one way of getting to the scholarships, and the second way is you can approach the academics because sometimes they've already got existing funds, and if they do, then and your skill set aligns with what they're after, then yes, they would be happy to pay a scholarship for you. Okay, so thanks for that. And I'll pass you over to Abhijit.
Thank you very much, Kiao. Yes. I think you have to stop sharing. Only then I can. Yeah.
Okay.
So I guess you can see my screen. Yep. Good. That's good. Thank you very much, Harrison, for inviting us for this nice activity you're doing at this difficult times and keeping everyone connected. Thank you very much for that, definitely. And thanks, Kate and Kiao, for making the platform ready for me to go make this presentation. So I'm going to talk a little bit different to what Kiao and Kate has said. In addition, I mean, there will be some similarities, definitely. Most of you would know me as till last year as a program manager for automotive engineering. From this year, me and Kia, we have swapped our jobs. I'm now program manager for mechanical engineering now on. And you would have seen me in teaching thermodynamics or through capstone project or remote area power supply and so on. Now, my story is a little maybe different, I would say, to others. I started as a TAFE student. So I'm not a mainstream student joining a bachelor's engineering degree after year 12. I did my, after year 10th, I went to a vocational school. I did my diploma in mechanical engineering like a TAFE. And then after that, I then decided to do a bachelor's, which is articulating. And there will be a lot of students within our programs, they do that. They go to advanced diploma, associate degree, and bachelor's. And you can consider me as a good example of or a success story of that kind of transition as well. After my bachelor's, I worked in the industry for a couple of years. I was not thinking about studying any further. I said that's enough after bachelor's, and went into industry. I had a job working for Vickers Perry. They were, I mean, it's one of the oldest British company making hydraulic systems and a lot of things. Then I worked for Eaton Hydraulics as well, and Sigma Industry. So I worked for a couple of years in the industry as a mechanical engineer, as a design engineer, as a shop floor engineer, as a tool room engineer. So I've got lots of hands-on in building stuff and designing stuff. But then after a while, I kind of was saturated with there's nothing new to learn anymore in the industry. I know everything because in industry, most of the time, the work that you do is is very routine. There's no opportunity to feed the creative and curious minds over there a lot of time. So then I decided, okay, how about I should go and do some further studies also to improve my increase my advanced skills in engineering. So went for master's by research, converted to PhD, similar to Kiao, up to 4.5 years or 4 years, close to 4.25 of a year. But then I started working at the same time, so I converted my PhD to part-time. So about 2008, I converted my PhD to part-time. I started working as a deputy program manager and educator, like a teacher at TAFE. And although a mechanical engineer by background, I was a program manager, deputy program manager for electrical and electronics engineering for advanced diploma students over there. And that's okay, because engineering, although you're studying mechanical or automotive or whatever specific field you are in, engineers are engineers. They should know everything, and we somehow eventually we have to know everything to get the systems working. So then after that, I worked as a postdoctorate research fellow, and since 2014 I've been a full-time academic. Now, what I would suggest, if you're thinking about further studies, follow all the advice that Kiam and Kate has provided you, definitely after your studies. But a good time to think about further studies will be when you're doing your capstone. So maybe third year, towards the middle of third year, you can start thinking about what you want to do with your future career. It could be further studies, it could be research, it could be industry, but choose your capstone project very wisely. Uh, is is Being at RMIT, you've got good opportunity. There's just so much variety of capstone projects, and there's a lot of very research focused capstone project to very applied capstone projects as well, and all of them are very useful from point of further studies or working in the industry. So even if you decide to work in the industry, I would suggest then in future, if you decide to come back to academia, having a strong capstone project would help you. So as I've worked in the industry, my capstone project during my undergraduate was in hydraulics. I worked in hydraulics industry, and then I did my PhD in hydroturbines as well. So it helped me show my potential in doing research in that particular field. So I'm going to show you some examples of some capstone projects that I've offered in the past and then I'm currently offering, and some of them how they transition to PhD. So this is a combined water and power project. I'm not going to go through the details. I'm just showing you the slides, examples of them. And so that schematic then turned up into a real actual working prototypes, and then into so that was a lab scale prototype and actual working prototype, which is ready for commercialization kind of setup there. Then there's a PhD student working jointly. Me and Kia, we are supervising on this particular project. And a couple of years back, I started looking into this particular area of reductor optimization, waste heat recovery as a capstone. It eventuates into a PhD. A capstone student who was working on this project now is working somewhere in close to Broome, Western Australia, in mining, and he is in contact with me, and he's quite appreciative of what he learned through this ejector project, eductor project, because mining, they use a lot of compressed air, a lot of water. They have to remove lots and lots of slurries, like heavy mixed semi-liquid kind of things, and this can be a very good jet pump kind of situation. So then there's this thermal power pump, and my research is also focused on water a lot. And this is a good example of an undergraduate student who started his capstone project with me. That was 2014. So 2014, the entire this student did his undergraduate project with me, and 2015 he started his PhD with me with a scholarship. A local student, RMIT. He had a full scholarship, and then he just graduated last year, end of last year, with full scholarship, and he's got we have got a patent, we have got plenty of research papers, and we are looking at we have got operating system, a real life thermal power pump system. Now, this is another example. This project has been going for a few years now, and it started as undergraduate. Now it's PhD. The PhD student has submitted his thesis and just waiting for examiners results. There's another capstone project which is on offer. We had a PhD student about 6 or 7 years back, or more than that, and he finished on this particular project as well. That's another example of capstone to PhD, which is thermoelectric power generation, which at present there is a capstone project student who's working with me to take this further. That's another example of a capstone project which converted to a PhD. So a student, you might, one of your tutors for mech design too, if you're a mechanical student, he was doing his PhD with me. He did his undergraduate project on heat pipes and vapor chambers, and he finished his PhD very recently. Now he's been offered a job in Japan at Fujikura. To date, I've supervised and co-supervised around 15 PhDs to completion, and I'm proud to say that all of those PhD graduates have got a very successful career. So a lot of them are working. That's another project. I will just skip to them. A lot of them are working in industry. Some of them are working in universities all over the world. About 4 of them are working in the university across the world. Majority of them are working in industry. 2 of them have started their own companies, startups. And there was a student who was working at a research institute, but now that student has moved. So not student, a PhD graduate was working at a research institute, similar to CSIRO in Malaysia, and now that person has moved to a university in Malaysia. So job prospects after PhD, or for future career after PhD, you can start out your own business, which always we encourage. Industry is definitely there. Industry is always looking for people with advanced skills. Research organizations are there, universities are there, definitely, but a lot of focus should be put on startups. Even as undergraduate, startups, I would say, always encourage. And that ends, I will end my presentation there.
Cool. So thanks for providing those 3 presentations. They've all given, hopefully, the audience some more information about postgraduate research at RMIT. So now, as we've done with the previous online sessions, it's time to ask questions. As usual, post these questions, please, in the chat rather than turning on your microphone. Cool. Someone's posted a lot of questions. Some of them were actually similar to what I was going to ask as well. So just organize between the 3 of yourselves of who wants to answer particular questions, and take your time. We've still got roughly 20 or 30 minutes to go.
I can answer the questions in IP. So, fun fact: after I finished my PhD, I became a patent attorney, and you can't actually be a patent attorney unless you've got a background in science, technology, or maths. So it's actually a cool career path that you can take after your PhD, should you choose to. So at RMIT, if you are developing technology, so you said you have power generation, if you develop that whilst an undergraduate student, and you've done that independently of anyone else on campus, you own that IP. But once you become a PhD student, it gets a little bit more complicated, because it's very rare that you'll be developing any IP on your own. What the university does in that case is that they basically come up with an agreement with you that you have the right to commercialize that technology, but the university will keep a license to it. All right. And the way they do that is they'll file all the documents, and then they'll give you a royalty at the other end based on how much income they can generate after they've recouped their costs. All right. And that's the key thing to know. They've got to make their money back first, because it costs $10,000 to file the full patent in the end. So that's, I guess, limitations from a student perspective around IP and commercialization. But if it's in the best interest of the university, they'll do everything in their power to make it work. We've got incubators and all sorts of things set up to try and take your technology and make it into a useful money earning company.
Maybe just let me add to that. For one of the projects where I mentioned we have applied for a patent. Maybe I should have mentioned that a preliminary patent, and it doesn't really cost much to apply for a preliminary patent. That's only valid for 12 months before we decide to go for a full patent, which Kate was talking about. That costs a lot of money. Now, in a lot of situations, university might decide that university doesn't want to be part of the patent application at all, where university does not see any long-term financial benefit, and then in that case, you'll have it in writing. I mean, you'll have to get it in writing as a student or as a supervisor that university or any other parties who are involved, they give up their right and they allow you to apply for patent on yourself if you want to go ahead, and then you're free to go and apply for patents on your own. Maybe you can add to that, Kate.
Yeah, no,
I just also add that I feel that it's a nicer safety net if the university puts the money up for you in the preliminary stages, because unless you know the market and unless you know that your technology is going to be successful, the university does that for you, and they will put up the money if they believe in it. And and if it fails, hey, you're not out of pocket. The university has gone and done that. So from that point of view, I think it's a bit safer than you doing it on your own. But that's my opinion.
And the last half of your question, what income's available above the 31,000? So the 31,000 is what the university scholarship will provide. You might find that if you can align your project with external industry interests or CSIRO as an example, there's capacities to get top-up scholarships on top of that. So whilst every other student's on 31, maybe you'll get a CSIRO top-up. That's another 7,500 per year. And you can actually put together quite a lucrative scholarship. But I've got to say, it's pretty rare. Most students are on that 31,000, and then they might make some extra money by taking on some casual work. So under the scholarship conditions, you can work about, I think it's 10, 20 hours a week. That's your answer. So a lot of students you'll see running classes, so labs, marking, doing demonstrating tutorials, and you get paid a casual rate to do that. The start date for next year, we like the students to start in Q1, which is I think it's the 31st of March or somewhere thereof. So you still get a summer break, and then you sort of come back and commence.
Maybe just let me add a clarification. So as a full-time PhD student with a scholarship, I think they are limited to work for 384 hours a year, like 8 hours a week for 48 weeks. As a casual doing tutoring, lab demonstration, but that's good enough income to add on to that 31,000, in addition to if you get any other funding from any external sources like CSIRO or any other industry. Now, I can answer. There's one more question. Who funds the working prototypes? As a PhD student, if you're working on a PhD project that needs experimental work, prototyping, building experimental rigs, some of them which I showed you in those pictures. Now, there's some limited funding available through the university to every PhD student that they can spend on equipment, prototyping, and things like those. But then in addition to that, usually supervisors, they have access to some external funds. For example, a couple of my projects, I had external industry funding the whole project. And so there was no limits really. For the thermal power pump project, I had a large funding from the federal government. And so there was basically lots of money to build equipment. So it depends upon the project.
All right, I see this question there from Harrison about examples of students from RMIT that have gone on to start companies. I don't have any examples from RMIT. I've only been here a few years, but I can say from my time at Melbourne Uni, we had a couple of PhD students who, have you seen those Neuro headphones? You sort of see them in shopping centres where the headphone adjusts to your hearing within your ear. That spun out of a PhD project where they were working on the bionic eye project, doing signal analysis and working out how to interpret brain signals. And they came up with a headphone company at the end of that, and they've gone great guns. Another example, also had the bionic eye project, which is what I'm more familiar with, was a group of guys who decided to take the technology we were developing in the bionic eye and develop a company called SmartStent, who you then take, the stents you use for heart surgery and use them in the brain to then be able to stimulate brain signals for paralysed patients. Now that got bought out by an American company called Synctron, and they're at home bathing in the cash. But if you have the right technology and the right drive to make it work, it's quite a possible thing to spin out your PhD.
I've just shared an example of the PhD student I mentioned who has started his company. I mean, he started his company while he was doing his PhD, not at the end, but that's a good example. So he started right from the start. I think it was 6 months into his PhD, he started looking into forming this company. So Ricketts Point Power is one of my ex-students. That's a good example.
So the start date for next year, there's 3 intakes, right, Kate? So one in March and one in July and one in October, I believe.
Yep.
So it's flexible when you want to start.
We prefer you to start in the first quarter.
What's the most
you can delay
exciting?
your start date.
What's the most exciting PhD projects that are going on? I'm just going to say mine, because this background image here is based on the transmission of COVID viruses from a sneeze. So we've had a whole load of surgeons come in because when they perform surgery, they generate aerosols, and they have basically been shut down and can't perform because they don't know how much aerosol is being dispersed in the air. So when you get these kinds of projects, you're like, oh geez, it's kind of having great impact. And where do I get the scans from the nasal cavities? They come from all the main ENT surgeons from Australia. So and one in New Zealand. So I work with a surgeon at University of Sydney, one in Adelaide, and one in Auckland. You guys?
I guess exciting projects is, relative to what interests you. So, I could say mine's the best, or Kiao's the best, or Abhijit's the best. But it kind of depends what interests you. Like in my field, everyone's obsessed with bioprinting, and I think it's like watching, paint dry. So there's lots of really cool projects, but it has to come from what interests you. So all the stuff we're doing in the advanced manufacturing space is really cool. All the stuff we're doing in the assistive technology and rehab space is really cool. Bionics is always cool. It's something that interests you and does good for society, in my opinion. But have a look at the list. There's there'd be 200 projects on that list. You might find one that you must do.
There's another question, Kate, for you.
Yeah, I saw that one.
Yeah.
You are an engineer. You are qualified to do whatever you like. So if I say biomedical engineering, that is a really diverse field. So some biomedical engineers work in soft, squishy polymer materials and cell biology. Some biomedical engineers work in medical devices and electronics. Some are just materials. I can't do electronics. I can't do squishy stuff. I am purely hard tissue, hard stuff. So being a mechanical engineer makes you no more or less qualified than me. Back yourself in and go for it.
Now, the next question, after tax, a graduate salary would be between 50 to 60K. What would pursue? I mean, that was the exact reason when I graduated 2001, the reason I went into industry, because I looked at the money. I started getting paid. I was earning. A couple of years I was working, enjoying my life. And then I got got saturated. I said, oh, there's nothing which was feeding my mind. I was getting bored every day doing the same thing. So that's what made me do PhD. That's our option. There's no good argument unless you are really passionate right now about research. You want to always create things. Depends upon your personality.
You've got to remember that the $31,000 you get is tax-free, and you still maintain a student card and all those concession discounts that you lose the second you go into the workforce. So that $50,000 that you'll get as a graduate engineer, you're going to lose 10,000 of that in tax almost immediately. So the difference between the PhD scholarship and that starting 50,000 isn't as far as it seems on paper.
But I also want to add, there's a freedom to learn, and you get to choose what you want to learn because of the passion that you have. So, if you're into, I don't know, 3D animation, you can go in there and learn it. And then you can use that to showcase your work. You're getting paid to learn, basically, and develop your skills. Whereas, I guess in the workforce, you have to be there 9 to 5, and you have to do what the boss says. So I think that's the main difference for me. And I agree with Abhijit. It's completely personality driven as well. If you've got that kind of curious, jittery mind that can't sit still, then a PhD might, address those desires to learn and try new things.
But then I would say if you can't make a decision in your 4th year, don't worry about it. If you feel like inclined going towards industry, go and do work in the industry. Just make sure you maintain a good contact with your academics, and maybe whichever academic you like the most, or you want to work in whichever field you want, like whatever is your passion. Just keep a good contact and maybe continue to do some side kind of research with them. Make sure you convey that your interest, the continuous interest to them. And even if after 10 years you do not feel like leaving the industry, no harm done. But if whenever you feel like I want to go back to academia, having that contact will matter a lot. Now, Kate, there was a question. What's the minimum GPA or WAM for international students?
Beautiful. So at the moment, you're looking at probably a GPA above 3.5, only because it's a very tight market, particularly at the moment with our funding cuts. But there's ways around that though. If you're an RMIT graduate, which clearly you're going to be, and maybe you've been lucky enough that in your capstone projects, you've published a manuscript, all these things add towards your score. So it comes down to who applies, what scores they've got, and you hope that you're above them. Particularly international at the moment, being onshore puts you in an advantage over a lot of the applicants that are going to come in because they can't travel to Australia.
Yeah, it's a numbers game. So I was trying to stress that it's a good opportunity for domestic students because typically the number of domestic students that apply is much less than the number of international students that apply. So statistically speaking, there's a better chance in that sense. Okay, the next question.
I think there was a question by Hayden.
Yeah, so I mean, Hayden, we can have a chat offline. I'm quite happy to have a chat to you about ways that we can build your career in the biomedical field without having a biomedical degree. I reckon I can solve your problems quite quick. I think you're going to be fine. I think you just need to get your product or get your ideas out there and start speaking to people working in the field. Every mechanical capstone student I've ever had working on a biomedical project has got a job immediately, without fail. I've taken on probably 12 mechanical engineering students across my time, and all 12 have walked into industry immediately in biomedical spots. So working for CSL, working for medical device companies, working for Planet Innovation. They've walked straight in because you've got the skills that biomedical engineers don't have. And last year, one of my guys walked into CSL. So CSL is a vaccine company. And I've never once had a biomedical graduate get into that graduate program. And he walked straight in because he had the CAD skills. He had a capstone project in a biomedical field, and they just went tick, tick, tick. So I think having the mechanical background actually is a strength rather than a weakness, for sure.
I'll answer the next one. RMIT does supervise industry-based PhDs. Typically, your supervisor can arrange that project in such a way that there is a research outcome from that project. So that's more specific to the industry project, and then also with your supervisor that you choose, and they can surely help reframe that project into a PhD type outcome.
The next question was about master's degree. There's no, I mean, it depends upon where you get your master's degree overseas from. It depends upon the overseas university. Its ranking as well. So a master's degree from Australia definitely is going to help you find a job within Australia, or even overseas. But depends again on what you want to do in terms of what type of industry you want to approach. If you are looking for small scale SMEs or medium scale industries, then maybe masters will not have that much value because industry does not have that much money to pay higher salaries, or there might not be higher ranked roles within that firm. So, but large multinationals, if you're working for General Electrical, Siemens, or you're working for Ford or Boeing, then yes, definitely a higher education is going to help you keep on the top of your promotions within the industry.
Okay, cool. Hope it's okay if I talk over this chat. Basically, yeah, I did an exchange program a couple of years ago and extended whilst I was there. So I did a year and I enjoyed it. Didn't ever think I'd do postgraduate studies, but just with this recession at the moment and how basically, you know, people are grads that already have jobs for the last year or two, they're being made redundant. So now the job market's going to be saturated and there's going to be less jobs being supplied with companies having less funding for this. I mean, I would have been thinking now more than any time would be the time to do postgraduate studies. So as of a couple of days ago, I'm now considering it. And I don't really have the grades for PhD, and I'm unsure if I'd want to specify in a topic as much as you tend to with the PhD. So I'm just considering masters. I'm just wondering how worthwhile it is, or if you guys would think it might even be worth just holding out and waiting for a job if someone's not too keen on postgraduate studies. Or I know this is a bit of an open-winded sort of question, but yeah, it's just
sure.
Unsure times.
Yeah. Now, what I would say, if you're a graduate and you haven't got a job and you're just waiting, then go and study. Don't waste your time, because every day you have doing nothing on your CV, that's going to put you at disadvantage with others. So I would strongly recommend, if you're not doing anything, if you're not working in an industry that you really like, that's your profession, then go and do your further studies. Yes, you might be working somewhere just to support yourself for your daily expenses.
That
yeah, okay, cool. Thank you very much.
It is a numbers game. So domestic candidates will have a lower GPA requirement. So we've had students that have got through with GPAs of 3.1.
Yep.
It just depends on who's applying in what year.
Well, if the planets align, I'll be getting a 3. So
yes, but as Kiao suggested, you know, if academic staff are winning external funding, they're not going to care about your GPA. The GPA only really comes in for scholarship rounds, which are centrally funded. But you know, if Kiao suddenly wins $1 million in the lottery, you know, just because you've got a GPA of 3 isn't going to hold you back.
Yeah.
Divide
Okay.
it by 30K. How many PhDs do I get?
But I mean, yeah. So more just wondering. Also, how good does a master's degree look in Australia? Because as far as I'm aware, correct me if I'm wrong, people tend to go, their honours degree, get a job, or their double degree, get a job, or PhD straight from their bachelor. As far as that's from what I've seen, I know master's degrees happen, but it just doesn't seem as common as it does in, say, countries like the US or Europe, or areas like the US or Europe. So do they hold much weight here still?
I think masters is a stepping stone for students who don't have a strong research background, and we definitely I would always encourage a student to do a masters, because when you finish your PhD, if you want to stay in academia, they always look back and go, how was your publication rate? What were your research outcomes?
Okay.
And you can follow on from your masters into your PhD, and you get a flying head start over everyone else. And the other thing is, you don't, it gives you a chance to actually test the waters of what postgraduate life is like. So if you do a master's, it's only 1.5 years, and if you don't like it, then you're out. If you jump straight into PhD, it's 3 to 4 years.
Yeah.
So you're locking yourself in for a little bit
It's a
longer.
big commitment. Yeah.
So masters is definitely a great thing to have, and you're still getting that postgraduate experience and postgraduate type of learning.
Yeah.
And the thing I find is when you go and apply for jobs and you're at a master's level education and you sit there amongst graduates, and not to disrespect them, but you you feel a little bit like, oh yeah, I've done a bit more, and you have a bit of a higher sense of confidence, because
Yeah, you're right. I mean,
not just because of the learning, but when you do your kind of research, you're forced to learn how to learn again in a different way. So it's a completely different experience.
Maybe let me also add that I'm assuming you are in your final year right now.
Yeah, I've just got 2 courses left. I'll finish mid-year.
Have you done your caps? You're finishing mid-year.
Yeah,
finished
I
your
did
capstone.
my final year project 2 years ago.
Okay, yeah. Now, I mean, for others, even for you, it might work. You've got another few months to spend within university. You can start working with your old supervisor and get some conference papers out, some research papers out. That might help.
I did my
to make you
research with where I did my final year project overseas, so my supervisor.
industry. Yeah. Okay. But then you could work with some other academic
Yeah,
you're
okay.
interested in, and maybe you can jump in. That's going to help, right? Having a conference paper with
Conference
3G.
paper, no.
No?
Academic
Journal.
paper, yes.
Yeah. Okay.
Yeah.
Good.
I'm putting a stop to conference papers.
Okay.
So there's a question there around kind of jobs that PhD graduates end up with in industry. So in my experience, they've gone into, I guess, research roles within large multinationals, because obviously they've got the track record in research. The companies don't mind greatly about your publication outputs and all that sort of stuff. They're just looking to make sure that you can walk into their company, follow instructions, rock up each day, and be an asset to them. So you'll see PhD graduates working in research roles. You'll see them in technical roles. You'll see them in sales roles even. You'll see them in customer interfacing roles. As I said, you can't be a patent attorney unless you have a science background, which, due to the difficulty of getting roles, means everyone's got a PhD. You'll see them in a whole heap of high-level roles. So it's that level above graduates, but you do also see them in graduate roles. So there's lots of opportunities out there with a PhD or without.
There was another question which I've just started replying to. Was directed to me. Mechanical engineering student was the best. So the electives, I would suggest maybe going into thermodynamics, mechanical design. So there's a mechanical design 3 as an elective taught by Martin Larry. And there's another elective, applied heat and mass transfer, taught by Kiao. Those are very good electives. Applied heat and mass transfer for thermodynamics, it would be a very good elective, and mechanical design 3 for mechanical design, basically. So
Okay, I'll answer the last
Yep.
few. So, the scans of the nasal cavities, I think I answered that. They come from the ENT surgeons from Sydney, University of Adelaide, and University of Auckland. There's a backlog of scans that we have that we need to recreate into computer models and 3D print. And for Anil, yeah, happy to discuss offline. So you can send me an email and we can discuss that as well.
And I'd always say masters by research, not masters by coursework. But
Yes,
that's just
I
my
agree.
personal opinion.
No, definitely by research.
The cool thing about if you start a master's by research and you really love it, it's actually not straightforward, but it's possible to convert from master's to PhD at your first milestone.
You'll get a more enriching experience too. Sorry, Kate.
Yeah, I agree. So I mean, if you're thinking about HDR, next year, there's nothing stopping you throwing your hat in the ring. You don't have to accept it in the end.
I had a student, got offered a scholarship, PhD scholarship, but didn't take it, and went off and got it and worked in a job instead.
There was a question about what specific roles do PhD graduates usually fill in the industry from your experience. I've got a couple of graduates who are working in Melbourne right now. There's a company called UMAL, so a multinational, and he's working as a design consultant. It's a building services company. There's another graduate, RMIT graduate, PhD graduate, who's working in a company in Port Melbourne that's called Blackmagic Design. He's a thermal design engineer over there. There's another graduate from RMIT who's working in Fujikura in Japan as a full-time and also a thermal management engineer. So basically they're working within their field of expertise, whatever PhD they did in, and that they become the specialist in that area. And so that's the, I mean, it's usually with a PhD, you can work in any field really, because you get that experience and that higher understanding of how to tackle large projects. So you usually end up being project leads, handling large teams of engineers, and you would be like overlooking. It's more like a sometimes managerial role as well. You can play a very key managerial role.
And defence likes PhD graduates. So DSTG, the defence companies out there, do have a predisposition to hire PhD graduates.
Was that all the questions, or were there any more? I've got a number of private messages mixed in with the public ones, so I'm not sure where we're up to.
Yeah, sorry about that.
I think that's it. I don't see any questions after that. Unless I've missed.
I guess the takeaway point is that we have 6 months now between now and the next scholarship round. So you've got plenty of time to go have a chat to academic staff or your friends or other students already in PhDs to find out whether it is a career for you. There's no right or wrong approach. Industry, PhD, whatever.
Now, there's a question which says, what master specialization would you recommend and how long would it take in RMIT? I mean, as said earlier, masters by research is better option. But if you want to go for masters by coursework and you're a mechanical engineer, there are a couple of masters within our school. There's Masters of Sustainable Energy, and there's Masters of Mechanical Engineering, and there's Masters of International Automotive Engineering. All three are excellent. So in thermodynamics, I would say Masters of Sustainable Energy is a good one for thermodynamics. If you're interested in thermodynamics, Masters of Sustainable Energy, which in the past was managed by Professor John Andrews, then Bahaman, and now it's looked after by Yasuhiro Tachibana. But you can email me, Kiao, or Kate, any one of us. We know them very well, and we can introduce you guys to those people.
All right then. So I guess we'll wrap it up there. We'll leave any of that last question there because we've gone past 7 o'clock, which I promised. So first of all, thank you, all three of you, for taking the time to speak with us, I guess after work hours, so to say. I'm hoping everyone in the audience learned a lot more about the opportunities that research, and particularly research at RMIT, can offer you. We were going to have a HDR stall at the MEA Industry Day. That has obviously been postponed till September 16th at this date. So if that goes ahead, there'll be more time to speak with any representatives from the higher degrees and research program. And I believe September 16th, is that before the deadline for scholarships?
Yes, yes.
Cool. So that works in perfectly then. So you have some time to think about it. Come along to Industry Day if it runs, and you'll be able to speak with people face to face, give or take whatever restrictions are in place at the time, and learn more about what opportunities there are. As I mentioned last week as well in our last presentation, while everyone is stuck at home, isolating, not having much interaction with the outside world, MEA have created a Discord channel where anyone can join, have a chat, talk about uni. We have a music channel where you can play music, talk about uni. Obviously, you cannot share assignments. We're policing that quite heavily. And most importantly, we're looking at creating some fun games that we can conduct on Discord just to keep everyone active and mentally healthy. James, you have your hand up. If that was a final question at all?
There was a question, final question. I think I've already typed in the answer for James, saying it will take 2 years to complete a master's by research.
Great. Okay then, well, thanks for your time. And next week we'll be speaking with Boeing. So I'll be sending out invites for that session with an aerospace company this time. So thank you once again, and we'll see hopefully the same attendees next week.
Okay,
Thank you
thanks.
very
Bye.
much.
Thank you.
Cheers.
Bye-bye.